Welcome to week 2 of our matter unit. Today's review is going to cover elements, compounds, and molecules. By the time we finish this PowerPoint, you should be able to answer the question, what is the difference between elements, compounds, and molecules? Before we get there, though, we have to go back to the basics of what is matter. Matter is everything around you. It's the chair you're sitting in, the table you're sitting at, the hair growing out of your head. Matter is anything that has mass and takes up space, and all atoms and molecules are composed of matter. And the matter can take the shape of solid, liquid, or gas. Starting with our solids, solids have a definite volume, a fixed volume. The volume is what it is, and it also has a definite shape. Molecules of a solid are tightly packed together. There is not a lot of space in between those particles of a solid. And at the same time, these particles are not moving around. They are not moving or sliding past one another. They are vibrating, moving ever so slightly, rubbing up against each other. Liquids have a definite volume, but not a definite shape. They flow a lot easier than than solids do. The particles of a liquid can move or slide past one another. And there's definitely a lot more space in between the particles in liquids than it is in solids. Liquids take the shape of their container, and the volume is dependent on the volume of the container. So when we say that a liquid has a definite volume but no definite shape, that means that the liquid will take on the shape of the container and the volume of that container. Gases have no definite shape or definite volume. There is lots of space in between the particles. They flow very easily. They are what we call the bump and fly. They can bump into each other and go flying across the space that they are in. We know that the more you heat up a gas, the more excited they get, and those particles travel faster. Gases will take on the shape and the volume of the container. For example, if we are standing in a classroom and I'm in a corner and I spray air freshener, the air freshener is not going to just stay in that corner. Eventually, those gas particles will have spread out and filled the shape of the classroom. So now the whole classroom smells like the air freshener. Now we can get into the differences between elements, compounds, and molecules, starting with our elements. Elements are a pure substance. Using our example here of gold, if I break down the element of gold to a single atom, that atom is going to be a gold atom. All of our elements are represented on the periodic table of elements with their own unique chemical symbol, and there are no two elements on the periodic table that are exactly the same. Our example here is gold with the chemical symbol of Au. Molecules are two or more atoms chemically bonded together. They also represent the smallest particle in a compound. So if we take a compound and we break it down to its smallest part, those smallest parts are going to be molecules. Molecules can be two or more of the same atom or element. Our example here is O2. There are 2 oxygen atoms. But we can also have molecules that consist of 2 or more different atoms. And our example here is H2O, or water, where we have 2 hydrogen atoms, 1 oxygen. Both examples fit the criteria and definition of a molecule. Compounds, on the other hand, a compound forms when one or more different atoms or elements have chemically bonded to form a new substance. Cannot stress that enough. In order to have a compound, you must have two different atoms or elements. They have to be different. And then that substance is represented by a new formula. So if we take the example of Na, which is sodium, and we chemically bond it to Cl, which is chlorine, you get sodium chloride or table salt. Or our trusty H2O, our water formula, if you take those two hydrogens and you chemically bond it to an oxygen, you get the new compound, water. They have to be two different atoms or elements to fit the definition of a compound. That is the difference between a compound and a molecule. When we are looking at our chemical formulas, in order to know how many of each atom or element that are present, we have to look at the numbers or even the absence of numbers that are there. Counting the numbers of different capital letters or elements tell us how many different elements are in that formula. For example, NH. N is a capital letter that is nitrogen, and it is next to a capital H, which is hydrogen. They are two different elements. A capital letter next to another capital letter represents two different elements. If there is no number in front of each of those letters, then there is only one atom of each of those elements. When we are looking at capital letters and lowercase letters, a capital letter next to a lowercase letter is one element. They go together. A capital N next to a lowercase a is Na, or sodium. Both letters go together. That is one element. A capital letter next to a lowercase letter that is chemically bonded with another capital letter is two different elements. Our formula example here is NaCl, good old table salt. You have a capital N and a lowercase a. We know the N and the A go together. That is one element, the element sodium. And it is chemically bonded to Cl. The C is capital and the L is lowercase. That is the element chlorine. The C and the L go together. So in the chemical formula, NaCl, there are two elements. Always pay attention to where your capital letters are. A capital letter is going to tell you that that is a different element from something listed previously. And then we have subscripts. So a small number placed on the lower right corner of an element is called a subscript. Sub meaning under. That's why the number is smaller and down in the bottom corner. The subscript tells us how many atoms of that element are present in the chemical formula. And remember, if there is no number, there is only one atom of that element. So looking at our example of Na2O, 2 is the subscript for Na, for sodium. The subscript tells us there are two Na, or sodium atoms in this formula. And if you look at the O, which is oxygen, there are no numbers. So that tells us there is only one oxygen atom in this formula. And to finish out our lesson for this week, can you explain this statement to somebody else? All compounds are molecules, but not all molecules are compounds. We will be discussing this statement in this week's Zoom lessons. Until next week, have a good one.